to answer these problems, normally you could easily draw the result, but I want it displayed in MATLAB. So I eventually showed you how to do that without doing scripting. Okay? Because when you do try to look over on Google, these signal operations, most of the time they teach you a script, which is a programming script that will implement your task, no? Given a set of signals. So, however, that basically is a bit complicated to do since an operation is performed only once on a given particular process and it's not repeated anymore. So hence, it becomes impractical to create an entire script just for that given particular operation. And in some cases, you often mix the operations, di ba? We shift, we fold, we scale at the same time. Nakuha ba? Therefore, it becomes impractical to like create a script that performs one particular operation or one particular task. It would be better if you could like incorporate all of those tasks and print out the signal. No? Nakuha ba? Mas okay pa yung ganon. Rather than creating a script dedicated for just one particular operation. Nakuha ba? So for this meeting, it will be a bit short, no? This meeting, since I have already explained to you the signal operation to do mostly on your given particular uh, process on your signal operations, no? Technically, if I show you the activity, okay, which was on your Blackboard, I've already posted on your Blackboard. Let me just zoom this and then share this to you. There, I hope you could see that, no? We already did like number 1, when we created the signal, tama, ginawa na natin to. We plotted number 2, and I even showed you how to do that manually, no? On your MATLAB, the scaling, the shifting, okay, and the folding, and then I even showed you how to decipher this. Okay, how to evaluate signals like this. Always remember the process, no, that you shift first, then fold, and then scale. Nakuha ba? That's the order of the process to get the answer correctly. And then on the last part, I actually showed you the odd and even component of your signal, which is basically your signal plus the flip of your signal, and then divide that by 2, di ba? Okay, I showed that to you last time, the odd and even component, no, of your signal, and we could easily plot that again. You could do that same process for continuous time waveform, which is the one that you're familiar with, yung mga sine wave, cosine wave, yan. Pwede nyo rin gawin yon. And each wave there has an odd even component, which is what you've learned actually on your Fourier series. Diba? When you break down the math on your Fourier series, you notice that bakit merong amplitude na AN, and then there's an even component, and then there's an odd component. That was mentioned there, no? Nakuha ba? It's because those are the components of your signal. Any signal has an odd and even component, no? Basically, I've just shown you how to display that odd even component on your MATLAB. That we ended there, no? Okay, and then for this next step, I gave here a particular block diagram on how the signals are eventually processed. So typically here, you could eventually, again, do a computation on how the particular signal should appear at the output waveform. Okay, comprising of the different input signals. I've also given there the different factors that you will use for your B0, B2, which are respectively labeled here to be, nakuha ba? So ayun yung values. Now, bear in mind that whenever you have signals like this that are in a particular block diagram, note that these signals do not subdivide, okay, into 2. Not like the ones you've learned on your circuits that whenever current flows here, parang gano'n, no? The current eventually subdivides into these different branches. Hindi siya gano'n, ano? It's not so with signals. It means that this entire signal also goes here, while this entire signal also goes here. Parang ganun siya. Okay? So, technically, nothing will be split up. Parang ganon. Okay? When dealing with signals, no? Under these particular conditions. So, we then observe what happens to the signal, try to process that onto our output. And then, what should be our given response, no? So the response would be a summation of these different signals. Okay? Note that there are different input values on different timescales. Hence, I will eventually add these signals on these given timescales. Note that signals are added based from timescales. Okay? Actually, you could perform that signal addition on your operation on your I don't know, MATLAB. I could just do signal addition there, no? Add nyo lang. Kunyari, X is a signal, nilagay nyo, X is ganito. Discrete signals to, no? Because the input values on top, dito sa taas na to, are discrete signals, di ba? Discrete signals yan. And what happens to your discrete signal? One particular discrete signal is multiplied by a factor. So every value on that given time scale is multiplied by that factor. Nakuha ba? And then one signal eventually is delayed. So nadi-delay ng one time scale. Tapos anong gagawin ko? I-add ko ngayon yung signal. Okay? As seen on this summation symbol. No? Nakuha ba? So if we want to basically come up with the actual output, we will simply derive the output muna, no? Nakuha ba? Okay, and to help you do that, basically I will assist you now so that you would know. So one signal for your x of n eventually passes through a multiplying factor first of B0. So here, basically B0 is multiplied to your signal x of n. Ganyan ngayon. So it's like a factor that you multiply. Every value on your signal x of n is multiplied by this factor. Nakuha ba? Okay. And then, your signal passes through this delay block. So it's called a delay block. So as it exits here, the signal becomes xn minus 1 because it's delayed by one time scale. Nakuha ba? That signal now goes down here and is multiplied by a factor of B1. So here, the signal now is B1xn minus 1 and then added to your signal here, which is B0. So xn. So what comes out here? It's simply the summation of the two terms B0 xn plus B1 xn minus 1. Nakuha ba? That will come out here. And then that same signal is now delayed here. No? Take note, this signal passing through here is only xn minus 1. Ito yan, ano? And it goes here. So it becomes now xn delayed again by one time scale, xn minus 2 na. Nakuha ba? Which is now multiplied by this factor B2. So at this output, you'd end up with B2 times xn minus 2. And is now added to this summation. So ma-add lang siya dito, magiging B2 xn minus 2. There, that's your signal output. Nakuha ba? This is basically your y of n. Okay, that's what we need. Now take note, each particular signal has 9 data values of underlying your time scale. Nakuha ba? Okay, so ano lang let me just go back up the slide, no? Up the, kasi do sa given value, you are to create 9 samples. Nakuha ba? 9 samples. Tapos anong ginawa mo? Yung middlemost sample is placed, yung gitnang sample, which is basically your technically your fifth value. No? Yung fifth value, dun sa amplitude mo na randomly taken, is placed at 0. Di ba? And I already taught you how to do that, right? Okay, o ganun siya. So yun yung input signal mo ngayon na xn values here. No? That will be fed actually here. Ayan. Here. Okay? So that's fed there. So when we feed it over there on your input value, then there would be 9 values again multiplied by B0. Tapos, these same values are simply delayed one scale, and we know how to shift them to the right, right? And then again multiplied by B1 naman. And then that same value is shifted again by one scale, which is xn minus 2. However, this time multiplied by your factor B2. Every value there is multiplied by your B2. Nakuha ba? And then, on a single time scale with an integer value of n, you write down and sum up all signals that are on that same time scales. Okay? O yun. So, ano-ano ba yung mga signal na, these signals eventually will overlap. Tama ba? Okay. Add all the signals that eventually overlap. That becomes your summation. Nakuha ba? Okay. Technically, if I declare this on your MATLAB as x, I should like place an annotation here. On your MATLAB, if I declare this as a variable, if I no, let's not do x kasi may x na eh. Let's not do x. Okay? Let's do a different variable. Nahilig ko sa x. Okay, A. Yan. Tapos ito, B. Ganun. C. O yun. Parang yan. You could technically just add them on your MATLAB if you're doing the MATLAB process. No? Just add the signals. So out comes an array of signals which are, again, the same array signals as your given value, of course, starting with the least value of n, and then you have to locate where the middlemost value is, or at n equal to 0 is, no, from that given output, because the output obviously will give you a matrix of values, no, and from there you could actually distinguish where n is, no, at 0, di ba? Hindi naman na bago yung time scale natin, na shift yung mga signals. The signals are shifted. Tama ba? Okay, so therefore you would know where the original middlemost value is. Just base that from where? I base it from wala. Dito sa xn, hindi ma-get eh. Okay? Then ko lang i-base ulit. Okay? Kung nasan yung middlemost value. Because here, xn has the middlemost value fixed at n equal to 0, which is your middlemost value, which is your fifth element. Di ba? Alam mo na at n equal to 0, lalabas yun. Nakuha ba? Okay. Nakuha ba? Okay. And each value is simply shifted. So ano mangyayari? Habang sinishift mo, dumadami yung nasa scale mo. Okay? Take note, since I'm shifting it to the right, therefore, signals, obviously, yung mga this xn has, 0 anywhere else. Ganun yung concept, eh, no? Okay? That means if I have these signals, that eto lang yung signal ko, then that means on any other value of x, 0 yan. Nakuha ba? So basically, positive 5 up, 0. Sa xn ko, sa xn, I'm referring to xn. Negative 5 down, 0 yan. Nakuha? But you don't need to show that negative 5 down. Okay? Bakit? All signals are shifted to the right. Di ba? So if signals are shifted to the right, therefore I have more signals at the right. Nakuha ba? So anong gagawin mo ngayon? Habaan mo lang yung scale nung that you need to display on your output. Technically, automatic na yun, eh, no? When you add the signals, MATLAB automatically do that because he knows that you shifted the value Therefore, the time scale for this particular value would be different. Nakuha ba? O yun, ganun na yun siya. Okay? And then when you add these signals, the array eventually gets longer on the rightmost part. Okay? Meaning -4, yung position pa rin niya on one end. And then madadagdagan yung values natin sa ano, until +6 na ganyan. Kasi dati -4 to +4 lang. And nag-shift tayo ng isa. So -4 to +5 na. And nag-shift ka uli ng isa. -4 to +. Nakuha ba? Yon, ganun nga yung mangyayari. And then the amplitudes of these values are eventually added together. And then that would be the resulting value for your y of n. Isang graph, one graph that adds all of these signals. Nakuha ba? Again, any question there?
None, sir.
Okay, wala. Okay, you could do that again, as I mentioned to you, like a calculator type on your MATLAB, no? Gawin lang natin parang calculator, declare the signals, then make a variable for xn, make a variable for xn minus 1, make a variable for xn minus 2, and then add the following signals. Lalabas array ulit, di ba? Okay, so like that, you could do that. Or you could actually display that same diagram onto your MATLAB using Simulink. Okay, so let's go over to MATLAB and let me show you how Simulink works. Okay, so let me share that MATLAB to you and demonstrate to you how Simulink is done. Okay, let me again share my screen. Ayan, I hope you could see my MATLAB. This is the online version again. I'm trying out on the online version. Therefore, please bear with me. Medyo mabagal yung ano niya talaga. Mabagal yung response. Ito is a bit slow because I'm doing this online. Okay. So, how do we access Simulink? Actually, there's a button here that accesses your Simulink here, found on your toolbar tab, or you could just simply type here Simulink, basically, and then press enter. And then the templates are given to you. No? So there are predefined on your Simulink that you could actually use. Normally, you apply this to show and simulate control processes and basically just check how they work. No? Of course, hindi ito ano, no? There are no moving components here. There are no animations. If you're looking for animations, I don't think MATLAB could do that unless there's an added patch tool for MATLAB, no, that does animation for you para yung values literally are animated to you and not graph or plotted. But usually the output here is simply a graph or a plot, no, just like what we have done on the ordinary MATLAB workspace. Okay, so basically there are pre-built systems here like that you could do, like the feedback, control, etc., etc. Okay, there are different communications. You have the DSP system toolbox here that you could have, no, and usually applied. Ito yung ginagamit, no, in DSP system toolbox sa atin. Okay, I'll just start off with a blank model here and create this workspace. Okay, ayan. You could actually give off a title for this, although technically kahit wala pa naman, no? Kahit wala naman, okay lang. Let me just enlarge this. Okay? So kahit walang pangalan yan, okay lang. Untitled or something like that. No? Okay lang. Hindi pa naman tayo nagsasave. Okay? And then, much like any of your given simulator, which I believe you're already familiar with if you're familiar with different simulator circuits like I'm sure you manage to use logic simulators like Logisim, NI Multisim, Logic LY, ano pa, all of those simulators. Eventually, halos exactly the same din yung ano, no? This is how your Simulink works, exactly like that. So meaning, The area, the workspace area is a drag and drop environment. So drag and drop environment pa rin to. Okay? And there are toolbars here on the left that eventually you could access. So meron ka agad siyang help. Nakikita nyo annotation. You could have zoom here. You could have uh, a scale here or different worksheet, or basically I could incorporate that into one particular smaller model. Okay. So first things first, we need components. So just go over to the library browser. Punta ka lang dito. All components are seen on the library browser. So a new window will pop out like this. Okay. And let's say I wanted to input values there on my given particular system. So you usually refer to as sources. Okay, so on the sources, again, you have a lot of sources here, a lot of possible sources that are predefined already. And all you have to do is like set their values. That way you uh, you you customize the output for your given required signal. Okay? So parang ganon. Okay? So meron dyan, there are a lot of signals here, including clock signals that you want for timing circuits. Meron din siyang clock input here, etc. etc. Meron siyang sine wave, meron siyang pulse generator, meron siyang repeating sequence. That is if you have a repeating sequence. Meron siyang random number generator. Kaso nga lang, when you plot this, it's like ano no, hindi siya stem diagram. It's like the one I showed you last time, that mga peak values are simply connected by lines. Okay? O ganun siya. Ganun yung output niya pagka discrete signal niya, no? Yung random number generator. But again, this is very useful, no? This is exactly the same one that used for your discrete signal. Nakuha ba? Except that the output waveform would be just like lines connecting your peak values. Ganun lang, no? Okay? Line lang, nagko-connect ng mga peak values. Ganun lang siya, no? Lumalabas. Okay? Which is awkwardly different from a stem diagram that we already know. Nakuha ba? Kasi alam natin na output stem diagram. But on that note, kasi walang stem diagram output dito for graph, eventually I will allow this random number generator. Yan yung allow ko. Kesa gamitin nyo yung ano no, uh, other inputs, no? Kasi nga dapat dito continuous yung waveform. It looks like continuous waveform, but on the discrete signal, obviously we know that these are ticks, no? Okay. Pero for the demo purpose, hindi ko naman iba yung gagamitin ko, no? Ano lang, iba lang. So you have other sources there repeating, etc., etc. You have here a signal generator. Okay, so the signal generator basically is a varying waveform that you could input, and then other than the frequency, you could your time scale, etc., etc. Let me just ano lang, simple lang. I'll just use a sine wave, here, and then basically onto your workspace. Okay. There. So, nasa workspace na natin. I'm just dragging it here under from the... Ayan. So now we have a sine wave, and actually you could vary the parameters of the sine wave by simply double-clicking your sine wave. So you'd end up with a block here that shows you the parameters of your sine wave, no? Basically, the amplitude there is simply 1. Parang ganun lumalabas, no? Okay, hindi natin makita yung total block parameters because we inano ko naka-append kasi to. Ayan. Okay. Hanggang dyan lang, no? Kasi hindi ko natataas ito. Ang limit niya hanggang doon sa window. We could actually remove that header here ng window para umangat pa ng konti, no? Pero okay na yan. Ang kailangan ko lang naman baguhin is simply the amplitude. Like for example, I'll change this, let's say, into 2, okay, or something, 2 times your student number or something like that, no? Parang ganyan, okay? So now that I've changed the amplitude value, Okay, so tunay amplitude niyan. Okay, and let's say I wanted to like multiply that signal, okay, by a factor, by a certain factor, then uh, you usually look for it in your um, tools here. Okay, now there are a lot of tools here, masyado maraming tools here, ganyan. You could actually enter the item here, and then he will show you the the location where that particular item is. No? However, you have to be a bit specific here when you ipapakita niya sa inyo lahat, or basically I could just like double click on the workspace and then do a search. Okay, as long as I know the name, no? So a particular multiplier or yung natin ginagawa natin, 'di ba nagmo-multiply tayo ng certain factor on the signal dun sa drawing natin ano a while ago. We're multiplying like B0, B1 and B2, 'di ba? Oh, so that basically is referred to as a gain on your um, simulator. So it's a gain that it either increments the value by a certain factor or decrements the value by a certain factor. So let's just select the simplest gain, which is this. And then you could actually drag this around and notice that it aligns itself on the block, making it easy to interconnect elements when you're using the Simulink. No? So that's one of the special feature of the Simulink now, that when you align these blocks, they form a connecting line, and all you have to do is to click that and they're connected already. Or you could do the traditional process by clicking one end and then drag connecting it to the other end, no? Clicking the other end. Pwede rin ganon. Pero ito yung feature ni MATLAB ngayon, ang magandang feature ng Simulink. No? Let's say I wanted to improve this gain by, let's say, a multiply of 3. Okay, or actually pwede mo rin i-double click yan. You could double click this and then have that window open to you and then change the gain value to 3. Pwede rin ganun, ano? So dito, I just click on the item here and then pwede mo rin baguhin yung value doon. Parang shortcut siya, no? That way you could easily change any value there. Actually, meron din yun dito sa ano natin, sa sine wave natin. You could also values immediately, okay, by going through the block itself. On the upper tab, may makikita kang block. Yun yung block nung signal waveform. Nakuha ba? And then from there, you could actually rename it, etc., etc. Nakuha ba? You could add an image, you could place a comment. Nakuha ba? Pag ganun siya. Okay. Now, the next part means, obviously, I need to see the output of this given waveform. To see the output of any given waveform on your, regardless whether that's a discrete signal, no? Kasi discrete signal yan, take note, as I mentioned a while ago, if it's discrete signal, he simply gets the peak values and interconnect them. Kino-connect niya lang yung peak value. Okay? O, ganun siya, no? So it still becomes a waveform some sort, no? Parang ganun, nagiging waveform pa rin somehow. Okay? So I want to see that outcome, and again, you could actually click the library browser again to view for that particular device that will help you do that, which is technically a scope, just a scope, no? Yung oscilloscope, yun yun, basically. Or you could double click again the worksheet and then the stripe scope there. Since I already know the command there for scope, so medyo medaya na ako kasi alam ko na yung command, no? Okay. And then there will be a tab there that says scope. Okay. You could double click the item again, click that tab, and you could see that inputs of the scope, no? And there are changeable parameters there, which is technically the ports. So there's a one port here is provided. I could change that, meaning I could display several waveforms at a time, and they overlap on the waveform. Automatically changes the color of each waveform. That way it shows you which one is the input, which one is the output. You could put a legend there on the much like what we do on the MATLAB workspace, no? Original MATLAB workspace. Okay? O yan. So, for now, isang munang ano, and again, just align this. I'll just align this to your gain. Oh, ayan, gusto ko lang para parehas yung distansya, para ma-arte si sir. Ayan. Ayan, no? So I already connected the scope. We could now see the output waveform of the gain, no? So just by double clicking on your particular scope, okay? Let me just make this into, that way we could see the original and the gain. Palitan ko lang ng 2. Okay? Yan. Okay? Ang ginawa ko lang is basically I just changed the number of ports. I added one more port so we could see the difference between the actual signal and the signal that was amplified 3 times. Nakuha ba? Okay, so how do I do that? I get the signal from the same sine wave input, and then I fed it back to your scope. Okay? This is technically done by simply, if you click this arrow, basically, ano lalabas, you and drag this around, you could remove this connection and then drag it around and connect it somewhere else. Nakuha ba? But what I want to do is to branch it out like what we see on the diagram a while ago. Tama ba? And connect it here on this port. That way, we could see 2 signals entering our scope. One, the original signal, and one with the gain. Nakuha ba? So I'll just basically right-click this signal, this arrow. Ay, sorry. Okay. Wala, na-left click ko. Sorry. Balik natin sa dati. Okay. I'll just right-click this arrow, and from there, drag it out. Habang naka-right-click ako, nag-drag out ako, and then connect it here on this port. Nakuha? How it's done? Okay, o yun. After that, basically, all we need to do is to simply view the signal and then run the simulation. Okay, so when you run the simulation the process will eventually compile, and then later shows us the output of the waveform. No, although hindi pa ako nag-save, mag-run naman tayo. So it's basically compiling the process and then getting all the results, and all you have to do is basically double click the scope to see the output waveform. No? Medyo mabagal yung pagka-online. Okay. So I have here my original signal in blue. Okay. Ay, hindi ko pala na-change yung amplitude. Sorry, hindi ko na-change ng 2. Oh, anyway, hindi ko na-enter. Okay. Hindi ko na-enter yung bagong value na 2. Basta sinara ko na lang yung ano yun. No? Okay. Anyway, ayan. It's shown here in blue that this is the original input signal, which is the amplitude of 1, and then the gain, the multiplied signal gain, or the output signal in yellow of our gain. Nakuha? Okay, so walang problem there, no? So what if I wanted to, let's say, add signals? Okay, what if I wanted to add signals? So again, just click over the uh, library browser. So in here, nakabukas pa kasi library browser ko. And I wanted to add, let's say, 2 signals. So gawa lang ako, I just get another signal generator here and then add it there. So for example, yung ramp. Okay, ito na lang ramp. Okay, meron ako ramp signal, meron ako ng sine signal, no? Okay, I get that, drag it on my workspace. Place there, wala na akong babaguhin dun sa parameters niya, no? That way, I keep it simple. So, hindi ko na babaguhin yung, ano niya. Hindi ko na babaguhin yung input niya. Okay, I think it's by default 0.3 yung ramp niya. Tama ba? Oh, a slope of 1. Lagyan natin ng 0.3. Okay? So nilagyan ko ng slope na 0.3. That means it means it will increment 0.3 yung ramp natin until it reaches a certain maximum value. No? Tama ba? Let me check. Okay, initial 0, tapos mag-slope na taas ng pataas. Okay. Okay, so yun yun. And then, let's say I wanted to like add these signals. Add ko yung signals. So again, just click over your library browser. Again, nakabukas na sa akin kasi. And go over math operations. Punta ka lang dito. Okay, because you're doing signal operations. No? Okay. So punta ka lang math operations. Click mo lang yan. What happened? Ang bagal. Ayun, medyo mabagal sa ang bagal sa ayan, within the math operations, you could see that you could actually perform various operations. You could divide signals, you could add signals, you could multiply signals. Ito yung gain ko, nagmumultiply ako ng constant value on your signals. You could even declare exponential functions or even create your own complicated function. Pwede kang mag-create ng complicated function mo, which is basically itong function box na to. Itong may algebraic constraint na yan. You could do that and use that. No? So meaning you could define your own function there and the MATLAB will perform that no, on your process. Okay? So ang daming operations dito that you could actually do but on our given end. No? O dyan, tingnan nyo na lang kung ano yung mga kailangan nyo. Yung product, you have a particular device that uh, adds up the complex and the real part and the imaginary part of your signal. Okay, nag-add siya. Etc. etc. You could technically reshape your waveform. Nakuha ba? O ayan, makikita niyo naman dyan. So ang gagawin ko na lang, mag-add lang tayo ng signals. So I'll just click this component no, and add two signals and drag it onto our workspace. Okay? So ito yung basically parang adder natin. And then I'll just align this kasi tinatamad ako mag-connect. And I input the ramp first on one of the signals. You could actually have this add subtract signals. Just simply make this plus signal into a negative para magsusubtract siya instead of adding. No? So kapag ka plus plus, mag-a-add yung dalawang signal. Kapag ka plus minus, magsusubtract yung isang signal. No? The other signal will subtract. So you need to determine which one is the subtrahend and which one is the subtractor. Di ba? Yung negative mo becomes the subtractor. Yung positive mo will become the subtrahend. Ganun ngayon yung output sa kanya. Ako ba? Then, I'll just tap here again on my signal and then place it here on the ramp. So, dito na lang sa original signal natin. Mag-right click lang ako uli. Okay? And then, connect it here this time on my component that adds them. So ito yung parang bilog na may plus a while ago on our diagram. No? Okay? It's that signal. And then of course, I need to view the output waveform of this given particular signal. And again, you could view the individual waveforms for amp or the sine wave that you have on embedded scope again. No? Pwede naman ganun. So I'll just add the scope again here. Maglagay lang tayo uli ng scope to view the output. Okay. And then, pwede ko ulit gawing 2 ports or 3 ports. Pwedeng ganun, ano? So this time, I'm making it 3. Okay, kasi I wanted to view the inputs as well as the output. No? There are 2 signal inputs here. So gusto ko ma-view yung output, which is basically this signal. That's the output or the added signal. And then I wanted to see the input signal here for my ramp. And the input signal here for my sine wave. Okay? So again, as soon as it is connected already, you could simply run the simulation, and then he goes on to compiling again, simulating the values, and then displaying that on your scope. Obviously, if you have more components there connected, you'd end up with, of course, uh, a more uh, longer time to compile the process. No? Nakuha ba? O, parang gano'n. No? So, kapag mas marami talagang component, mas matagal talaga mag-compile, basically. No? And view the process. Okay? So, let's just double click this so we could see the output of the waveform now. So, ito ngayon yung output natin. Okay? You have the original uh, waveform here in red. Ito yung input natin now, amplitude of 1, di ba? Na sine wave. This is the ramp. Ito yung ramp natin that continues to increase all the way to 3 here kasi hanggang 10 lang yung scale na dinidisplay niya. You could actually display more, longer time scale. Just click on any of these particular process here, no? Magagawa mo yon. And when you add the signal, literally yung ginagawa niya lang, i-add niya yung signal per amplitude, no? Nako ba? Per point. So, ano nangyari sa waveform natin? It continued to increase and increase and increase. Tumataas ngayon yung waveform natin. This is the resulting added waveform of the two signals. Nakuha yan? Nasundan? How you could actually make use of the Simulink to demonstrate the outcome for your given number 5. Nakuha ba? Okay, so actually, it's an optional task that you could do. Pwedeng gamitan mo yun, pwedeng, I actually showed you both how to do that. No? Basically, de-declare mo lang yung variable. Tama ba? O yun, parang ganun lang. And then, add the signals, which is actually much easier to do. But here, you could actually visualize. So, MATLAB has this new feature that allows us to visualize the output of the given particular system. Nakuha ba? Now, bear in mind that this particular system only outputs waveform. Therefore, when we try to like detect if a particular part should be moving, therefore we need to have like an indicator for that. For example, I want to see if that device is rotating. Okay, I want to see if it's rotating, gumagalaw, umiikot. So paano yun? I'll just create a a uh, a waveform for signal output for my angle. So habang tumataas yung angle ko, my graph eventually will increase. Di ba? That indicates that as time progresses, my angle increases. Di ba? Gumagalaw nga yung angle ko. Nasundan? Yun yung ibig sabihin. No? So parang ano, lalabas doon, you need an output and declare that as an angle. Parang ganun siya. No? And it becomes a waveform. And you have like know how to interpret that waveform, whether to know whether the device is actually moving or not. Because I've mentioned to you that Simulink does not basically animate or your simulation, but rather it gives us uh, discrete output values in waveform. Okay, much like our ordinary MATLAB. Nakuha ba? Nasundan yan? How to do that? Okay, so hopefully that would be very helpful to you, especially when doing those activities for uh, activity 3. Okay? So, ayan, ang dami, there are a lot of processes that you could actually do there. And you could create a subsystem, no? Pag hin-highlight mo to, basically highlighting them all, you could actually create a subsystem. Pwede ko siyang gawing block ng subsystem, pero you don't usually include the inputs there on a given subsystem. So, ayan, kinuha niya yung blocks na ano daw yung subsystem de. Okay. So, pwede kong i-highlight itong part na to. Ayan. Kasi ito yung nasa loob ng operation ko eh. No? And then create that as a subsystem. Parang ganun. So gagawa siya magkikreate siya ngayon ng subsystem and a block that will contain all of those components. Isang block na lang yung makikita mo. Nakuha ba? It's much simpler. Tapos yung block ko, may dalawang input, merong 5 outputs. Nakuha ba? Ganun lulalabas dun sa aking block. And you could actually uh, create that. Ayan na, naging block na. Di ba? Naging isang block na lang yung components natin sa loob with the respective outputs now displayed here. Nakita ba? O, ayun. So, ito na yung isang block. Ang laman nun yung ating kaninang gain tsaka yung ating nag-a-add ng signal. Okay? So, yun yung laman nitong system na to. You could double click that to see what's inside. Ayan na yung laman on the inside of your subsystem. So there's a lot of basic system that you could actually incorporate within MATLAB that will eventually work for you, especially when you're creating like a design or you're creating something like a system for your research. Ayan, no? Marami kang magagawa dyan using MATLAB. No? Sabi ko nga, you could define your own function there. You could include a lot of features there. In your MATLAB, no? Okay, and then your MATLAB now offers this special feature na ano na, no? That automatically incorporates them on a given particular subsystem. So that's another new feature incorporated in the new Simulink, you know, that was uh, introduced by MATLAB. Okay. So yun. Other than that, of course, the usual standard format, you could convert this into a code. Pwede mo i-convert yan into a code, isang operating code on your MATLAB that will help you do that. No, nakuha ba? Pwede yun. No? I could have that into a code and then have my variables placed there on the code. Automatic siya na maglalagay, and then later I could just upload that on a given particular, let's say, Raspberry Python that accepts MATLAB program. No? Uh, I think it's .r, ang extension name niya. So you could have it executed by your Python, Raspberry, or ano ba? Maraming processor na pwedeng gawin yung Arduino, Raspberry, maraming portables na ano eh, no? Na nowadays, no? Guisdino, okay? Maraming portables na processor that you could actually use to implement your MATLAB program. And with that, makes it more compact, no? And of course, it allows you to create the program here on the environment and then convert that into a code. So that's one of, again, the standard feature ng mga Simulink models that were created before, whereby you could automatically generate the source code for this given model that you have created. Nakuha yan? So that's one advantage of your MATLAB, no? Nakuha yan? Hopefully you manage to get all of that kasi I'll be if there are any meron mga question? Hindi ko na isa-save. Any question there?
Answer.
Wala. So malinaw yan ha. Kasi I'll be leaving you now to work on your activity number 3. Okay? And that will be due by April 12. Okay? Yung activity number 2. Sorry, 3. Okay? And I'll go through your activities now and try to grade them one at a time. Okay? So, kung wala ng question, kindly turn on your cameras for a few seconds so you will be recorded within our session. This serves as your attendance for our meeting today. Okay, gusto ko rin i-end na yung session kasi nagbibidyoke na dito sa amin, ang ingay na. Naririnig nyo na yung videoke. It's overpowering my voice. Okay, wala atang camera si Harold at si Ronald because they're not turning on their cameras. Anyway, yun, si Carlson nagbukas na. Yun, si Harold. Okay, ayun. Okay, so thank you very much guys for joining in our session. Thank you, thank you. Stay safe, stay healthy. Yes, you may log out of our session now and do the activity. Thank you guys.
Thank you po,
Thank
sir.
you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you po, sir.
Thank you. Stay safe kayo dyan.
Thank you, sir.
Stay safe.